In previous video we already discussed about how to write the minterms and maxterm for the given binary code. So we had taken example for the three variable boolean function. So for three variable, how many different values we generated? 0 to 7, total 8 different values we generated, and accordingly we also discussed about the minterms and maxterm combination, and this is similar to the 4 variable. Now let us go to the next about to how to write the notation format for any boolean function. Now here I am taking the one boolean function abc plus ab dash a dash b dash c plus a b dash c dash. Now it is a sum of product format. Now tell me the what is the minterm of a abc. Minterms are obviously they are a product term, so we can also recognize from the boolean function. So for this function the minterms are become m7. abc means m7, a b dash c means m6, next one is a m1, next one is a m4. Okay, so now the boolean function can also presented in the format of a minterm combination, minterm notation. We can also write it. Okay, now these minterms are summing one to each other. So obviously we can write as a sigma of m7, m6, m1 and m4. Okay, in a right format we can also write as a sigma small m of 1 comma 4 comma 6 comma 7. Now this function can also represented in this format. The last one is a proper format to represent a one boolean function. This is a normal boolean function. We had a lot of practice about how to write it. This boolean function, now by using the minterm combination we can also represent in the last line format. Sigma small m of 1 comma 4 comma 6 comma 7 also equals to this boolean function. Okay, now onwards let's write the boolean function in a minterm notation format. Okay, similarly for maxterm how it will be. So here it is a maxterm. There are I have taken some terms, a dash plus b plus c dash something. So what is a maxterm for the first one? m5, next one is a 6, next one is a 3. Okay, next one is a 7. For 7, a dash plus b dash plus c dash. Obviously we know that from the table. Now all are producted one to each other. The product value in a mathematical format we are represented with the pi of m5 comma m6 comma 3 7. Okay, actual notation, the final notation to represent this boolean function will be pi of capital M of 3 comma 5 comma 6 comma 7. Now this boolean function is equal to this format. Okay, both are same now. Now let us go to the one problem. So every time they may not be in exam, they may not be asked directly with the boolean function. They can also ask in the format of a minterm notation directly. So sigma small m of 1 comma 2 comma 3 means how many minterms are there? First minterm, so that is first let us go to the, in any question if they are asking, first we need to recognize how many input variables are there. There are only two variables. For two variable, how many different values we can able to generate? 0 0 0 1 1 0 1 1. Only 4 values we can able to generate, 0 to the 3. Now here the 1 nothing but a dash b, 2 nothing but a b dash, 3 nothing but a b. Okay, there is no forward, there is no fifth word, sixth word, seventh word. It is only for two variable. So whenever you go for write the solution for any problem, also you have to concentrate on how many variables are as a input for the boolean function. Based on that one you have to write the term, because one nothing but you may also consider like a 3 variable one. In 3 variable minterm, what is the value? A dash b dash c. So that is a value of a 3 variable, but here it is only 2 variable representation, so that you have to write the minterm accordingly 2 variable only. Okay, then next we can also simplify it. This is the question. Can you able to simplify? Yes, we can able to simplify with the Boolean algebra postulates. A dash b plus a, if you take the a common, and this will be, and you already know that the formula of a plus a dash b, that is becoming a plus b. So this is the answer for given boolean function. Okay, so the question in the examination in any format they can able to ask as a minterm notation or else a regular boolean function. So anyone we can able to take, and we can also simplify. Similarly for what is the POS of a Boolean function? Here this is a different kind of question. You must be remembered. In the previous slide just I have explained that how that format can able to the question format will be asked for the simplification. The next one is there is some question a comma b comma c, sigma small m of 135 are is the question. Then what is the POS of this Boolean function? But it is already in a min-term combinations are nothing but they are in a SOP format. Just you remember sigma small m, nothing but it is a SOP format, because the product terms are summing one to each other. Sum of product term, min-term nothing but here it is a here the question is that what is the POS of this Boolean function? POS, product of sum. You remember this point. You already know that min term, you take a one term for the min term and you apply the inversion, you will get the max term, and you take a max term and apply the inversion, you will get the min term. So that is a relation between min term to the max term. Similarly, in any question there is a min terms are given, and to identify the max terms, very simple answer is that write the terms which are not in the given question. Write the terms which are not in the questions or belongs to the POS format. The question already in a SOP format. If they are asked for the POS, write the terms which are not in the question. Write the terms who are not in the question. Here 0 is not, 2 also not, 4 also not, and 6 also not. You write them and they are belongs to the max term. They are belongs to the POS format. Similarly, if the POS is in the question, you write the terms which are not in the question, they will become to the SOP. So that is the relation between POS to the SOP for the min-term and max-term combination. Here I am asking one question, sigma A, B, C, D. Now there are 4 variables are there. How many different values we can able to generate? 0 to 15. So that pi capital M of 0 to 4 some terms are given. Then this function is in a POS format, because they are a max-term combination. So they are POS format. And what is the SOP of a Boolean function? Will be, what is the SOP of a Boolean function? Terms you write here who are not in the question, they are belongs to the SOP. They are belongs to the SOP. 1 is not there, 3 is not there, 5 is not there, 6, 12, 14, 15 are not there. They are comes under the SOP format. So that is also relation between the given max term notation to the min term notation. Okay, let us take some example from the let us discuss in the paint. So here I am taking the one example for the relation of min term to the max term. A very simple one, sigma small m of and first we need to concentrate on f of how many variables are input. Here only 2 variables I am taking, 2 variables a comma b. Okay, a comma b, only 2 variables are there. Nothing but how many different values we can able to generate? Only 4, that is a dash, b dash, next one is a dash b, and next one min terms. They are becoming min terms. Now a, b dash, next one is a ab. So these are the terms we can able to generate for the two variable. Now it is a small m0, this is a small m1, this is a m1, this is a m2, and this is a m3. So this is a notation for a 2 variable min term combination. Similarly, you will get the max term, that is about a plus b. It is starting from a plus b. So you already know that how to write the max term. Okay, now here I am going to explain that sigma small m of 1 comma 3. So this is my question, 1 comma 3. Now it is in the which format? Small m, nothing but small m. What is the one value? What is the one value of a binary Boolean function? So 1 nothing but here a dash b. So here I am writing a dash b. So I am asking that simplify. Okay, a dash b plus next one is a m3. What is the m3 value? ab. Okay, 2 terms I have taken. Okay, then how to simplify it? Take a b as a common, then inside we can see that a dash plus a dash plus a. Now a dash plus a will become 1. Entirely the result of this Boolean function will be b only. Okay, now accordingly here I am also asking that so this is a SOP format or POS format. It is in a SOP format. We already know that the min term notation will represent the SOP format. Now the question is that what is the POS of a Boolean function? For the same question, what is the POS? What is the POS? You must be understand. Okay, POS. What is the POS? Now POS will be the terms which are not in the question. Here I am taking capital pi capital M of the terms which are not in the question. Who are not there? 0, 2 are not there. 0, 2 are not there. So they are become a max term. Okay, then you can also write the max term for the 0. So the 0, that is only two variables, so that a plus b, this is my function a plus b. Okay, into what is the 2 nothing but 1 0. What is the one value? A dash. In max term we have to write as a dash. So here we need to write the max term a dash plus b, a dash plus b. So this is the max term 2, capital M2. Okay, so a dash plus b. So this is a Boolean function for the this is a Boolean function in a max term combination for this given question. This is actually in which format this question? The question in the min term notation. Then max term notation will be so this format. This is a max term notation. Okay, for the same question min term notation, and for the same question max term notation. Here it is only covered the 1, 3 term. The remaining terms are belongs to the max term. The function will be a plus b dot a dash plus b. Now for this function S4, and it is in a POS format. Now it is in a POS format. Okay, max terms are going to be represent the POS format. Min terms are represent the S4P format. So this is a relation you must be understand. Okay, similarly we can we have a lot of questions we can able to prepare, but once you get the clarification about the relation between S4P to the POS in a M notation, easily we can give the solution for every question. So let us go to the another question like not sigma. So first initially I am writing as some question a cap M of a comma b comma c, a comma b comma c. So simple I am simple question here I am preparing. In case there is a sigma small m of so there is a some terms are given 1 2 7 are in the question. Okay, so small m nothing but sigma small m means the given question in the which format? S4P format. The given question in the S4P format. Okay, simply we can able to write what is a Boolean function. The given question Boolean function will be a dash b dash c, the first term. Second 2 also covered, a dash b c dash. Then 7 term also covered now, so that a b c. So this is a S4P of a given Boolean function. Now similarly, what is the POS for this Boolean function? For this Boolean function, what is the POS? What is the POS? For this Boolean function, what is the POS? So POS will be the terms which are not available in the given question. The terms which are not available in the given question. So the capital M of who are not available, 0 is not there. We can able to take 1 is there, 2 is there, 3 is not there, 4 not there, 5 not there, and 6 also not there. Now for that question the max term notation will be, you can see pi capital M of 0 3 4 5 6. 0 3 4 5 6 is become a POS of a given S4P formatted question. So this relation you must be remember. Okay, see we can able to write the format of max term notation. You already know that terms are getting multiplying one to each other, producted one to each other. So okay, so accordingly we can able to write for the 0 3 4 5 6. Let's write, nothing to worry. Let's write for 0 the function will be the function for 0. What do you mean by the 0? Here a plus b plus c, it is a 0 term. Next term will be 3 nothing but 0 1 1. Here a plus b dash plus c dash. Okay, next one is a 4 nothing but 1 0 0. Okay, 1 0 0. Okay, next one 5 and 6. What is the 5 value? 1 0 1. So that a dash plus b plus c dash. Okay, next one is a 6 1 1 0, so that a dash plus b dash plus c plus c. So this is a function notation for in a max term combination. Okay, in a max term combination this is a function. Okay, in next example we'll discuss about the more problems on min terms and max term combinations.